All right, as Mr. Greger mentioned, I do live in this watershed, so this is a personal thing, yet I do get paid freshly to do this. I get to play in rivers throughout the whole United States and Canada. So I'm honored and humbled to be here. Thank you. Go for it. All right, so we've touched on it to some extent throughout between Rob and Igor's presentations, but according to an organization called Society for Ecological Restoration, their definition of the term is activities that initiate or accelerate the recovery of ecosystem health, integrity, and sustainability. Now, goals of that, and I did prioritize these in my professional opinion and somewhat personal opinion, would be restoring the natural flow regime if possible. We don't know that yet. Habitats and water quality, public education and engagement, and honestly, that could have been number one. It really could have been. I sat there and debated, and probably I'm a bit biased given this is my profession. I'll admit that. Recreation and aesthetics and infrastructure protection, and honestly, that could go up as well. This was I was just somewhat pulling straws, debating. I could have gone on and on like a dog chasing his tail. So according to SIR, Society for Ecological Restoration, that's the definition. And I love the new, relatively new term, correct? Reconciliation, Peter Moyle. He coined this, right? No? Okay. I love it. I love it, nonetheless. Next slide. So within that, kind of a subcomponent is what is stream restoration? We can call it enhancement. We can call it reconciliation. I'll run with restoration right now. Again, you'll see flow augmentation is up top. As Rob mentioned, if we can return some natural flows, the channel will have to be augmented because right now it is, most of it is a very long riffle from really from 580 down, more or less. And I have recently walked the whole extent. That includes enhancements that will have to occur to the bed form so that we can have riffles and runs and pools and glides. And that's kind of how water moves, working upstream to downstream. We all that have been backpacking and have to cross streams, you'll typically cross it on a riffle. The riffle will run, it's fast, it's shallow, and then it gets slightly steeper. We call that a run. So you're kind of running into a pool, and then here comes this pool. Pool is gentle, flat water surface slope, if you're out there surveying it. And as the pool transitions back to a riffle, we call that a glide. It glides out. What's critical about the glide is that's typically where most of the fish will spawn. And there has to be particular size gravels, particular slopes of those glides, so that that can be conducive for whatever species we're going for. So those conversations and that research would have to occur to look at bed form enhancement. Now, can we add various in-stream structures such as log and rock? Can we look at various tow wood revetments? Of course, native riparian vegetation, and I know the eucalyptus subject is a big one. I live in Estadio Estates, and it's a big subject. I want to get rid of them, period. I know it's not that easy, and I know it's not that easy. I do know how to run a chainsaw. Okay, floodplain connection, that can be a critical component of rearing habitat for fish if they can get here. Floodplain wetlands, kind of same as category above. Stormwater treatment, as Bert alluded to, we have urban stormwater runoffs. We need to look at more low impact development type of features and try and incorporate those into them so we can treat the water like bioswales. Can we capture the rainwater runoff on sidewalks? Can we incorporate some sort of component of rainwater catchment on private land? And, you know, hey, throw it out there, dam removal. I don't think that's realistic, but put it out there. But that would be included within stream restoration in a general sense. Next. Okay. Well, the critical science of understanding why and how this riffle run pool glide thing works is the science of fluvial geomorphology, a relatively new term, relative 80s, 70s-ish. I would give Aldo Leopold's son. Anyone read San County? Luna. Did a lot of research in Wyoming, and then landed at Cal, and is widely regarded as the godfather of this field. But what does geomorphology mean? It's simply a branch of science concerned with the influence of river and streams on the formation of the earth and its surface. What sort of processes are involved in fluid geomorphology? We have erosion, we have some sediment transportation, and we have deposition. Now you notice we have deposition and erosion. Ooh, that's somewhat contradictory, is it not? No, in balance, not excessive. There has to be some of both. Next slide. This was a conversion of Mac. No, that's fine. Really critical that when the term fluid geomorphology came out back in the 70s and 80s, and still to this day, there's still a battle being fought amongst the traditional engineering approaches, who simply look at a few factors. They go, oh, we can restore this. We'll look at just A and B. And they're completely missing the boat. When you get into fluid geomorphology, the ecology of it is so much more math, it would make your head spin, actually, than a traditional engineer would look at things. They typically go, how much water and how much sediment do we need to pump in and out? Just get it out. Those are simple equations. The ecology side is much more complex. Now, fluid geomorphologists, as I consider myself a novice, there's no real certification to get licensed as such. So we've had a hard time fighting for our rights to sit at the podium of these engineers. The good news is that the engineering field, with mixed results here in California in the Bay, but the rest of the nation actually has embraced this, and it's moving forward, and there's a much bigger merger here. But it includes, we have to have planning, design, evaluations, well, planning, design, construction, evaluations, and obviously the critical component is communication amongst all of them. Next slide. Okay. Back here to local situation. Currently, and Michael's touched on this, still kind of going through, and I'm speaking really as a Friends of San Leandro Creek member and as a homeowner here. There's continued stakeholder engagement on multiple levels. East Bay Mud, East Bay Park, City of Oakland and San Leandro, Alameda County Flood Control District, various regulatory agencies. Obviously, public is implied within the City of Oakland, both servants, public servants, and citizens. And I think there's almost everybody here. Is there anyone from Alameda County Flood Control? Well, all right, Hank. We're talking. The groups are talking. So what's next? Well, and Rob hit this. What is the vision? And Igor has had success with this. And then let's develop a plan with everyone at the table. We need to identify opportunities and constraints. Funding is a big constraint. Private land ownership can be a constraint. It can also be an opportunity. I would definitely argue funding right now in the state of California is a constraint. We need to get funding to do the analysis, to figure out what realistically can be done. Is this even feasible? We need to understand that data. We need to start to implement, be it in phases, trial runs, and then we really need to monitor to be honest and humble and transparent and assess whether or not that was effective. Next. So can we get flows that are sufficient to meet our goals and objectives? And we've kind of thrown out there loosely that we want to get steelhead in the system. We haven't mentioned if we want to get steelhead up near the dam to spawn in the existing habitat features that are good, or do we want them to spawn and live sustainably throughout the whole system below Lake Chabot? That's very different projects. That hasn't been really worked through yet. We need to look at the whole watershed and do an assessment. We need to understand the hydrology and hydraulics related. We need to look at risk. Anything done still has to protect the public for the 100-year flood event, I would assume, and that's why I want an Alameda County here. That's okay. So when we talk about these in-stream structures, when you run a a flow model, we can't increase that water surface elevation because then we're jeopardizing the public safety. So I'm assuming that anything we do here, that has to be included. We need to look at how can we connect the floodplain. I've touched on some of these things and some of them are blurred out, so we're gonna go to the next slide. All right, here's the fun part. But until then, because this may take some time, what can we do, or what can folks really in particular along the creek do? And it's a term called soil bioengineering. So I'm going to transition from big picture to a little more hands-on. And it might give you a sense of renewed optimism. I'm going to pass these around. Feel free to smell it and kiss it. And we'll start in the back here. Yes. All right, next slide. What is soil bioengineering? Anyone ever heard of this before, or who hasn't heard of it? Awesome, awesome, okay. It is a technique that uses plant materials to mimic natural conditions in a stream in order to accomplish certain objectives. Bank stabilization, erosion control, and habitat quality, and I could go on and on and on. Next. That was timed, right? Next. Okay. It combines structural, biological, and ecological concepts through the use of live plant materials and other flexible engineering techniques. Next. There is a history. It goes way back. Talking 28 BC, Chinese and Roman empires, in fact. What I'm handing, passed it around to you, is a wattle, second bullet point. No, that's a fascine. The only difference is they're oriented in a different direction. Now, in the 16th century, it became increasingly codified and practiced and monitored. And then really it ramped up in the 30s, believe it or not, under Hitler. They kind of let this one guy just go out and play in the wildlands. And he really pushed this subject. And then since then, the NRCS, and including projects in Lake Tahoe Basin and Redwood National Park, have moved this concept forward. Believe it or not, there are engineering standards, even from the U.S. Army Corps of Engineers, that are adopted. And we can look at rigid standards that are applied to this technique. Otherwise, it sounds kind of like a bunch of hand-waving. We don't like that in the engineering field. We need standards. Next. Before you even think about doing anything on your creek, if you live near or know someone that lives near this creek, you need to be aware of multiple jurisdictions that are in play, that have legal rights, even though you own it. You obviously, I'll start at the local city and or flood control district may need permits for you to do anything. Let's then branch it out into Regional Water Quality Control Board, generally meant to enforce the Clean Water Act. Then we get up to the state level, California Department of Fish and Wildlife now, formerly Fish and Game. And then we actually break it up into the federal level, U.S. Army Corps of Engineers, and then they can be subbed out into multiple other federal agencies. So that bundle there is willow posts, and the other one is a willow wattle. Next slide. I'm going to show a few techniques that actually can be done on your own once you check in whether or not you need a permit. You know, you can choose, it's your land, you can choose to not seek a permit, but I would advise you should and need to. But that's your call. So erosion control blankets. And all these things would be probably components of any sort of reconciliation, enhancement, or restoration that would occur here. Now, these are made out of 100% generally biodegradable materials, such as coconut, straw, that doesn't last too long. So I'll go from the ones that last the longest down to the ones that last the least longest. Hemp and jute last a long time, 3 to 5 years. Woven blankets down to coconut, 2 to 3, and then down to straw ones. We don't want the ones with the plastic. Those are typically not even allowed in this area. In other regions, they are allowed. There's differences amongst these local regulatory agencies, unfortunately, throughout the state. Next. Now, what is it about willow in particular that allows it to be so conducive to be the major driving force of soil bioengineering? Well, it actually contains a ton of growth hormone, kind of like the type that Bonds used. Slightly different. It turns out that research has shown that the root systems actually have a very high tensile strength value, and that is of the pulling, this pulling, kind of like what we have to deal with earthquakes here. And in fact, some argue that it's stronger than concrete. Yet, it absorbs the energy, it doesn't reflect it. That's a beautiful philosophical paradigm. And it's very resilient to lots of changes in the hydrology, in the hydrograph, to potential climate change impacts. Next. So one of the other techniques that we can do is those willow poles or posts. I trimmed those this morning. You cut them, remove them. The pieces you removed from the thicker diameter pieces are what made the wattle. So I used most of everything I cut. You literally stick those in the ground. You want a 45-degree angle on the bottom, top cut flush, trim the nodes down, and you want 2 to 3 nodes above ground. And those little nodes are what eventually turns out to be those branches and the branch collars. And sometimes when they're perfectly straight and it's a similar diameter, it helps you to know what's up and what's the bottom by cutting that 45-degree angle on the bottom. So that increases your surface area for the roots to come through. The top being cut perpendicular helps to seal it up. And as long as that willow post has access to the vadose zone, or you tweak that and you irrigate it yourself, it will grow. Next. Slight delay. Okay. And next. There's a wattle, and it's really just the bundled pieces of material that I cut to make the post, alternating. So tops and bottoms, and just bind it up. You then lay it in parallel to the stream flow. The fascine, a different technique, is perpendicular to stream flow. It's okay. And you see a lot of the Caltrans projects where they break the road cutout with those straw wattles. Similar concept in that if we're dealing with rainwater runoff, we want to prevent downslope erosion, so we want to break that flow up. But along a stream, if we get water or we provide temporary water, they will grow and provide habitat, help possibly to shade the water and offer nutrients and possible food through the bugs that may fall into the creek. Next. Now we're getting more and more complicated, but this brush mattress can be a really effective technique to implement, very cost-effective per foot. And it's simply, you have an exposed bank, you do a little demolition, remove the non-native veg. You can lay down an erosion control blanket, which I talked about. You then lay brush, you lay it down towards the creek. You then install a grid of wire or construction stakes or mesh, and then hammer it in. And Pam worked on one of those with me a while ago. Pam's in the audience. And I've been playing with this technique for years, and I've been pushing the known federal literature in that I think it has more applications. That project you're looking at was done in an urban environment on Cornices Creek with steelhead. Upstream creek was concrete vertical walls, both sides, and bed. Downstream, concrete vertical walls and bed. Opposite bank, concrete vertical wall and bed. This was the only piece that wasn't. So the traditional engineering folks would say, you are crazy. This is going to blow out so fast. This was years ago. It has withstood flows above it, and it's a living green wall. Next. Now, more and more complicated. The photo that Igor showed at the Martinez Adult School is something I helped build and design, and it is using a technique called brush layering. It's simply lift by lift, kind of pillow by pillow. You lay soil with an erosion control blanket. You compact it to about 80% compaction rate. You then lay willow facing the creek, and you can see that it's somewhat insloping, and you build lift by that way, and you can literally rebuild a stream bank. That's what we did at the adult school. And in fact, that year, it withstood the flow of the El Nino years and did not move. that year. So the roots weren't even there, which means we probably got the fluviogeomorphology right. Next slide. There's a photo of it. That's more on a lake, which can be done too on a shoreline. Okay, next. All right, in summary, I know we're running. I appreciate everyone sticking in here. San Leandro Creek, I have a vested interest. I'm not planning on moving for a long time. I'm an avid fly fisherman. Boy, that'd be neat to have steelhead there. I doubt they'll become viable so that I can actually fish, but it is ambitious, but I think it can be achieved, but it really is going to need our input. We obviously need to return a more natural flow regime, and we need to understand if it's even feasible. In the meantime, soil bioengineering can help landowners and can help all of us possibly reduce some of the stream bank erosion that is or may occur in the future. And last, that's a photograph of one of our projects in Colorado. It's really neat. So I'm a resident. I get paid to play in this field, and I look forward to what may happen here. Thank you. Thank you.
So thank you all. I do want to introduce Bert and is it Vanessa? Representing East Bay. Well, no, I don't know if you're representing East Bay Mud today, but you're definitely here, and I want to thank you for coming on out. And we do have a growing relationship with East Bay Mud. I just need to point out that with the pending project of the seismic retrofitting of that dam, we engaged East Bay Mud, and we didn't know really Bert or Vanessa existed. And here we were going like loggerheads with the engineers whose focus and being is to build, repair, you know, it's an engineering. It's in their DNA. It's like the fish. They want to go, and the engineers want to build. And yet here we are. An entire other part of East Bay Mud is their watershed department, which you are part of. And we're learning to work with them. and meanwhile, still building the case to work with them on balanced water flow. So it's a long process. There's many stakeholders, many jurisdictions. We're not there yet, but definitely we are putting our best foot forward here. So again, thank you all. Stick around if you like a little, and get out there and I'm sorry. Don't stick around. And I would like to now hand over to Susan, our coordinator.
I want to thank everybody for coming out today, and I think that our displays were awesome, and I want to thank every group that came out today. Wonderful. And I really want to mention again that we're doing this new job with East Bay Mud and the City of Oakland, the City of San Leandro, and East Bay Regional Parks. Thanks so much, Doug. Flood control. Bart. So we're really beginning this communication with all of these agencies, and it's so exciting to get all of our stakeholders here and represented. And we have so many more people who would love to get to be players. For example, the Ohlone people. And they have such historical importance on our creek. So it's really exciting that we're getting all of these communications beginning. It's wonderful. And my last thing I'd like to say is, if you're not a member of Friends of San Leandro Creek, please, on your way out, we're very affordable, but become a member. There are some blue flyers over by our display, which is this one. So please join us. And I want to thank everybody again for coming, and go out into the sunshine. It's a beautiful day outside. Thanks so much.